So, Jiva, we've begun to briefly sort of overview collections, and we spent quite a long time looking at NSArray, which introduces us to quite a few of the principles in ways we're going to be doing things with collections in Foundation and Objective-C. So, in our overview, we've mentioned more than just NSArray. So, which one are we going to look at next?
NS Dictionary. Okay. You know, NSArray, like I said, we just looked at that, and that's an example of an ordered collection in the collections classes. NS Dictionary is an example of an associative collection. So it's a collection where you store objects with keys. So let's take a look at some code. Basically, to create an NS Dictionary, again, you know, I mean, to declare it, you know, it's NS Dictionary, pointer, standard object declaration syntax. But to actually create one, a lot of times you'll use these initializers, such as this one here. This correlates to that array with objects dictionary, or array with objects factory. But in this case, because you have to provide both a key and an object, in other words, you know, the object that you're going to store and the key that you're going to use to get it back, you have to provide both the objects and the keys. So here we're showing that we have objects foo, bar, and baz, and we're storing them with keys 1, 2, and 3. Now, because of the fact that it's this associative container, we also have to provide the count. I believe there is also a factory method that takes a nil terminated list as well. But for me, I kind of prefer to use the one with count, because when you use the nil terminated list, you wind up with these constructors that, or these initializers that just, you know, have these huge argument lists. So I find it easier to just say, look, count 3. That way I can use that.
Now, I'm assuming that just like an array, we can stick anything in the objects.
Yes.
Are there limitations of what we can use as keys? Do they have to be strings? Can it be strings and numbers? Can it be anything?
Well, the limitation on the keys is that they have to have the ability to generate a hash against it. So you have to, like strings, numbers are okay, things like that. But if it's an arbitrary object for a key, it needs to provide a hash function.
Okay.
Okay. And that would be a function on your object that you're using as a key. So now here's a factory method as well. Same thing, you know, same thing as the initializer up above, right? It's creating this dictionary with objects and for the keys. Another common constructor that you might use with NS Dictionary is this one here, which actually gives you a dictionary with the contents of a file. The Foundation framework has the ability to read and write plist files, which are property list files, and treat them as dictionaries. A property list is basically a file that contains name and value pairs, just like a dictionary. And so you can read and write these files using the NS Dictionary class. Now, typically, you might create a plist. Like in Xcode, there is a plist editor in Xcode that you could like put it right in there. Another option might be there is an XML form for plists that you could use any text editor to create. But generally speaking, I would say I use this kind of constructor most often when I might have created an NS Dictionary in memory, and then I want to persist that to disk and then call it back. So I might save it out as a plist and then read it back in as a plist, because there's another function on NS Dictionary called write to file, and that'll write out a plist for you from an NS Dictionary object. So pretty cool stuff there. And of course, like I said before, you know, there is this nil terminated constructor that you could use, just like the NSArray. Again, I prefer to use the count ones, but that is available to you.
I always find this one confusing, and it's got nothing to do with it's bad or anything, just my brain doesn't work properly, because I always want to do the key then the object, and yet this demands the object then the key, and
correct,
it always
yes.
and it makes sense in the method. It says with objects and keys. It's not like it's not telling me that, but my logic just wants it the other way around.
Yeah, and I also tend to, you know, this is sort of formatted to keep it all on the screen. I myself tend to sort of like type off the end of the right hand side of the screen. So if you just listed this out, then about the middle of that line you'd start going, what was the key for what object, kind of thing.
I always format this call like that.
You format it like that? See, I was just going to say,
otherwise it's unusable.
Exactly. This is the only way that you could really format this call, because then you can actually kind of look at it and say, okay, object, key, object, key, object, key. But even with that, it's still confusing. I don't like it. So essentially, that's how you construct dictionaries. And again, it's just like an array. It'll store anything you want. And again, it's storing those objects as ID types. So that's all good.
So an NS dictionary, just to remind ourselves again, is immutable.
An NS dictionary is immutable.
Set up, we can get stuff out, but we can't put anything else in.
And of course, there is the NS mutable dictionary, which is the mutable variant of NS dictionary.
It's early, don't worry.
Boy. So now here we've got actually accessing elements of that dictionary. So if we had created that dictionary that I showed you in the previous screen, right? Here basically is how you get to one of those elements. You use the object for key method. And in this case, we're saying, I want the object for the key 1. And that should return to you, using our dictionary that we just created, that should return the foo object, right? Same thing here if we wanted to say object for key 2. Now these are just strings there, even though I'm using 1 and 2 and so forth. Don't be confused by that to think that this is an ordered collection. Those could be any strings that I wanted to. I could actually have switched those, and I could be asking for the foo, the object for key foo, and I'd get back 1, and so forth.
So what happens if I ask for an object for a key that doesn't exist? Does it return nothing, or does it fail?
It will return nil.
Okay.
So that's one way that you can check to see if your dictionary actually contains this key, is to try and access the key, and if it doesn't contain it, then it will return nil.
Okay.
Which also brings us to this second form of getting objects, and that is the objects for keys method, which gives you the ability to get multiple objects out of your dictionary all in one shot. Now, because again, you may not it may not contain all of the keys that you've specified. You also have to provide what's called the not found marker, which basically means that for the array that you're going to get back, if any of the keys were not able to be found, it will return this object, whatever you specify, instead of nil, basically. Mm-hmm. So typically you will use something like we're doing here, which is to use the NS-null null object, which incidentally is actually provided specifically for inserting null values into arrays and dictionaries and sets. You can use the NS-null null class to insert a null value into an array or a dictionary.
So it's a class that represents a null.
Right. Not to be confused with nil, which is different. It's a non-value, but it's a non-value valid object, as strange as that may sound.
And that's because we can only add objects to dictionaries and arrays, not scalars or nil or anything like that.
Right. You cannot insert nil into arrays or dictionaries or anything like that.
Okay.
Okay. So, given this situation, given our dictionary that we had before, if we looked for objects for the keys 1, 10, and 2, our dictionary before didn't have an object for the key 10, so we would actually get back foo, NS-null, and bar.
Okay.
Make sense? So next, let's take a look at iterating over the dictionary. Again, dictionaries support fast iteration, just like NS Array does. You can, if you want to, you can access the all objects method off of the dictionary, which gives you the ability to get an array of all of the objects that are in the dictionary. And then you can iterate over that array just like any other array. It's just an array, right? Mm-hmm. You can also, there's also another method called all keys, which you could, for example, use that to get all of the keys of your dictionary, then maybe pluck out every other one, make a set out of that, and then use that with that previous method where you were getting objects for keys and get out every other keyed object out of your dictionary. So there's all kinds of cool stuff that you can do with this. So there's the all objects, that'll get you all the objects. There's all keys, that'll get you all the keys. So this is just iterating over those objects. If you just iterate using the dictionary object itself. Remember we have this ability to do, for value in object or in collection, right? Again, you could be using ID here if you wanted to. I happen to prefer to use the actual type, but you could be using ID here. Then the default is actually to iterate over the keys. So what will happen here is we'll iterate over those, and each key will be put into that that iterate object there so that you can use it. In this particular case, you would use it to actually go get the object for that key and print it out. Now, as far as mutability is concerned, we already talked about NSArray with regard to mutability, but again, there is the NS mutable dictionary, right, which is the mutable form of the dictionary. And in order to insert new objects into a mutable dictionary, then you use the method set object, then your object, for key, and then your key. So really, to construct the same dictionary that we've been working with already, here's an example of exactly that. You set object such and such for key such and such. Additionally, in order to remove an object from your dictionary, then you can say dictionary remove object for key. I'm not sure if we actually covered removing objects from arrays, but just in case we did, in a little review here, you can use remove last object to get the last object out of an array, or you can also use remove object at index to remove an object at a particular index. Finally, you can also, using arrays still, you can do that replace object at index, passing an index with another object. That's actually a really cool method because that's very efficient. Rather than plucking something out, having it rearrange all the memory, then sticking something new in and having it rearrange all the memory again, instead you just in place say, I want to replace that thing that's there with something new. And it's a little bit faster than doing all that other stuff.
Okay.
So that's pretty much NS Dictionary. Let's take a look at NS Set. NS Set is an unordered collection. Essentially what you can do is you can say set with objects, just like, you've got this constructor, just like with array, just like with dictionary and so forth. And I believe that needs to have a nil on the end of it there. Just like those other functions, just like those other factory methods did. And again, once you've constructed the set by creating this new set, then in order to get one of the members out of it, then you use the member method, and that will actually return the thing that is equal to that member object. Now, personally, I don't really see much use for that personally because I've already got this object, right? So I'm not really sure exactly what you would use that for. More often than not, I usually use, there's the any object method, which will return any object out of this set. This is one that's actually used fairly often in iPhone development because you get a set of UI touches when you're dealing with things like handling multi-touch gestures and things like that on the phone. You'll get a set of all of the touches. And so sometimes what you want to do is say, I don't care which one I get, I just need one of the touches so that I can figure out, where the user is touching things. And so you would use the any object method to do that. Another way to access the objects in a set is to ask for all of the objects, which will give you an array of all of the objects in there, and then you can reference that based off of index, just like you would an array. You can also ask whether a set contains a given object. So in this particular case, we're asking whether this set contains object Baz, and in this case, it returns a Boolean value, yes or no, which because we're formatting this to a %LD, will print a 1 out because it does contain it.
I can see the use for that.
Yes, definitely. So that would be...
The member one, I have to say, I struggle with.
I don't know.
But there we are.
I'm sure there's some kind of complicated, computer sciencey reason to have that, and I guess there's some, case that actually comes into play. But.
Because it's worth pointing out, that member there, that's not a key, that is the object itself.
Right. Exactly.
So it's saying, give me this object.
But I have the object.
I'm giving you.
Yeah, I don't get it either.
Yeah.
But it's there. Anyway. So as far as doing things with the sets, you can create, so let's say we created this set, set with objects, and we've got this new guy here, and we say, You can also, is this the same? This is the same code.
Yeah, we've done that.
Yeah, we've done that.
Don't repeat yourself.
We reviewed that stuff already. You can also iterate over the objects in a set. So again, just like using the iterators with array and iterating over the dictionaries, we've got you can iterate over these objects. Again, you can use ID here to get each element of that set and print them out. Finally, you can also use the object enumerators again, and it should be noted, you could use these object enumerators on all of these objects. We talked about it with NSArray, but you could also have done that with NS Dictionary as well.
So can you take things out of a set?
You can take things out of an NS mutable set. So NS set does have a mutable variant as well as an immutable variant. Everything that we've seen here has been an immutable variant. But I don't want to belabor the whole mutable versus immutable point. The idea is, yes, there is an NS mutable set, and yes, you can remove it, just like you can remove objects from arrays
and you can add objects to sets.
Yes, exactly.
We're getting the pattern here, aren't we?
Yes,
and
it's all pretty much the same.
And one of the great things about Foundation is a framework is it's pretty darn consistent.
I would say very consistent, yes.
Meaning once you've learned how to use a collection of one type, you can pretty much probably guess how to use the different collections.
Yeah. In fact, and I think that applies across the board, not just to Foundation, but also to Cocoa and Cocoa Touch as well. If you start working with those GUI libraries, you'll find that once you've learned to use a few of the different components, for example, for displaying a button or for displaying a table and so forth, you'll find that the same patterns as far as how you use those components applies to almost all of the other components too. Apple's been really, really good about being extremely consistent in how you use all of the APIs in Foundation and Cocoa Touch.
Now, in a moment we're going to move on and look at some more advanced or obscure collection stuff, but there's something that we haven't really covered yet with collections that is important, and that's
memory.
What happens with our memory management when we're working with collections.
Right. So, one of the things that's a little bit confusing for new developers in Objective-C working with Foundation is when you're handing this object off to this array or dictionary or set, who owns that thing, right? Am I still owning it? Do I have to control it? And so forth? But really, if you think about it, really, our memory management rules still apply in that I can hand off an object to an array, and that array will retain it when it receives that object. When it puts it into the array, that object will be retained. So you only actually have to hold on to a reference to the array itself. You only have to retain that array itself. And when you release that array, all of the objects in that array will also be released. So that's a very important point to remember, is that by handing off control of your object to the array is going to do exactly the same thing that the rest of us do, and that is, I'm receiving this thing, I need to care about it, I need to own it, I need to make sure it sticks around, so I'm going to retain it. He's going to assume that what you're giving him is something that's going to be released or something like that. So if he wants to hold on to it, he had better retain it. So the standard memory management rules apply for that, and you need to remember that aspect of things. But there's also another little thing that is a little bit of a gotcha when working with removing objects from collections and memory management. So let's take a look at some code here. If you can imagine that we have this mutable array, okay, and it has the objects foo, bar, and baz in it. Now, if we pull out an object from that array, okay, so now we've got item here, and then I remove that object from the array. So here I'm doing remove object at index. Here I've gotten a reference to that object. Here, by virtue of the fact that the object is going to be removed, when the object is removed from the array says this is no longer part of my collection, so therefore I'm going to release it, right? So if I now try to access that element after it's been removed from the array, what's going to happen?
You may get an error.
Probably get an error. Yeah, because item will be released at this point.
Well, the only reason I say in this code you may get an error is because the objects, when they're created, are going to be auto-released. They may not have been auto-released yet.
Fair enough. You're absolutely right there.
So,
but
if this code had read, I'd allocated it and then released it when I.
You're right. You're right there. But
you should still assume you're probably.
Nonetheless, you're right. But nonetheless, the point is, this is the wrong way to do it. You don't want to just pull something out of the code and then remove it from the object, because it'll have its retain count released there. So in fact, the correct way that you want to handle this is, again, we've got this array of objects here. You want to pull that object out of the array, and then before you remove it from the array, you want to retain it. Now, one thing you could do here is, if you didn't want to worry about releasing that later, is you could retain it and then immediately auto-release it as well. And what that would do essentially is you're incrementing the retain count and auto-releasing it. So if you do nothing else with it in here, when you go out of scope, it's going to get auto-released down the road. And so that's one way to handle it. But either way, this is, the important thing is you need to remember that you need to hold on to that thing, or you need to increment its retain count, because when this comes, it's going to be released. You're going to get the retain count's going to go down there. And so therefore, at this point, it would actually be okay.
I mean, I think the key here to remember is, when you add something to a collection, its retain count is incremented. When you remove it from a collection, its retain count is decremented, and when you release a collection, it decrements the retain count of everything that it's within it.
Correct. And of course, if you use garbage collection, you don't have to worry about this at all.
Well, there we are.
But there are other problems with garbage collection, and that's actually one of the things that we will be talking about when we come back and we talk about some of the advanced collection features.
Okay, so that's arrays, dictionary sets, and memory management done. Go digest and come back for some more advanced stuff.
Bye.